All right, everyone, it is now 3:30, which means it's time for us to get started. Welcome back to COM 426, Modern Web Programming. We're now at this is lecture 10. So give everyone a chance to settle down so that we can get started with some announcements. Great, okay. So our first set of announcements, great job on the two readings. We're going to be going through the process of grading those. I know that it was long, but we don't have a reading now for a while, so you don't have to worry. We really just want you to kind of get a good kind of foundation for how how we specify UI in React, as well as how we manage state in React, so that when we're working on more advanced projects and assignments, you'll be able to have a good foundation for that. Right? And speaking of assignments, if you all saw the notification that popped up this morning, we have released the next assignment, which is A03, New York Times Games, and it will be due next Wednesday. Currently, that's the due date that we set at 11:59. So this is going to be, I think, hopefully a fun assignment. You're going to be creating both Wordle and connections, and you'll have a working version of the game deployed by the time you're done. You can share it with others. It loads in real previous puzzles from Wordle and connections. So I think it will be pretty cool. And just to kind of show what this might look like and what your final result will kind of look like, I do have here, this is what you will see when you're done. So you can see New York Times Games, you have a little thing at the bottom for your partners, and you can play Wordle. So Wordle shows up. You have a keyboard on the screen that you can type to make your guesses. I think there's an extra credit as well for adding a keyboard. So like typing in a guess like so. And you can keep guessing until you get it correct, and then it shows congratulations, etc. And then there's also connections, which loads in a game. You can click on different tiles to see if you have something correct. I will not be able to do this, I think, off of the top of my head, but I can click some random ones, and you'll see that when you press submit, if it's wrong, it'll shake. And if you do get it correct and you go through it, you'll end up having all the colors show up and you'll win. So if you haven't played these games already, I know they're pretty, especially Wordle is very famous the last few years. Definitely check it out. I would go onto the New York Times site and play these just so that you know how these games work. And then you'll have the chance to go through this assignment. All right. So I think it'll be, hopefully, even though it's a longer assignment, I think the final result will be rewarding to have once you're ready. All right. So kind of in that note here, because this assignment is a little bit longer, it is a pair assignment. You can work with somebody else. So if you already know someone, you can feel free to partner with them and get started. If you would like a partner, because again, you want someone to work with because it's a longer assignment, but you don't know anyone, totally fine. There is a link in the Canvas announcement that takes you to a Google form. You can fill out the Google form. There's also some questions about like your general availability and your working style, and I'm going to try to match those well so that you kind of have someone with a similar, maybe similar availability, similar kind of a style of work. And I'm going to release that either really late this evening or tomorrow very early morning, so that you have the full amount of time to work with your partner. Okay. One thing I'll note, because I think it did come up, I think early on there was a bug in the thing where it made you like select a check mark for every single row. So I have gone ahead and turned that off. So that should be fine now. All right. Any questions there? Great. Okay. And then the last thing here, there's a quick note. So A02 is graded. Everyone did an amazing work there. There was one thing, there were some submissions that were counted incorrect because of the Vercel link that was submitted. And so one thing that I want to note here is that in Vercel, they give you two options. They have a first link, which kind of it's not in the exact format that we say in the rubric. So that's kind of your way of checking what is correct and what is not. Because when you click on that, that brings you to the Vercel .com like page for your project rather than the actual project itself. And so if you submit that link, we're not going to be able to access the project because we won't be able to see it. So for going forward, make sure that you submit the correct link. Otherwise, in this time, if you got a point deduction for a broken deployment, but it was because of that, you can create a regrade request. And if you already created one and it got declined for whatever reason, recreate it again, because I did not go through it myself. So I'm kind of overriding here if anyone's regrade request got denied. Submit it again, and I will go ahead and and counted correct this time. But after this, make sure that you have the correct link submitted. And there are instructions on the new write-up for A03 how to check for this. Just go into an incognito tab and paste that link in. If it fails, then you know it's the wrong link. If you paste it in and it takes you to your project, then you know it's the right link. All right? Any questions there? All right. And regrades are open, I think, for the assignments, so you can feel free to do it at any time. All right, so with that, let's get started with our content. So today, we're going to kind of be rounding out our portion of talking about core React features. We first started out by talking about creating React components, this idea that we encapsulate UI and state together in these building blocks for our applications as components. We talked about that on Tuesday. And then on Thursday, we talked specifically about how we manage state using React's useState hook. And this was kind of the main part of reading 5 and what it was really talking about. How using useState, whenever we change a state in our app, maybe through an event handler or something like that, pressing on a button, it re-renders our view so that it shows automatically our UI changing based on the state, right? So we don't have to set up manual kind of how we did in A02, where you have this controller section, the event handlers and syncing. Don't have to do any of that. So, and then also we kind of talked about this briefly. This is kind of the same thing, right? Whenever a state changes, we're triggering a new re-render. And once we re-render, right, we have a component function for our React component. We rerun that function. It produces a new UI, and then React will modify the DOM to match our new UI, right? So we kind of concluded with that on Thursday. And so in total, we end up with this kind of relationship where we have UI and we have state. And in React, whenever we change our state, it ends up automatically updating the UI. So we only really have to worry about that one direction. And in this label 1, we don't have to worry about the reverse because React handles that for us. Any questions so far? Amazing. All right. So what I would like you to kind of think about now, we're going to be extending this model a little bit, which is that in A03 New York Times Games, right, we are going to be loading data from an external API or from an external resource, right? So in order to create a new connections game, right, you're going to request for a new game, and it's going to give you kind of what the answer is that you can, then the game can be played. Or in Wordle, whenever we are trying to load a new word, or when we load a new game, right, we should get a 5-letter word back that says this is what, is the answer that the user is trying to solve for. And so if you remember back, this is kind of what we use. This is back in the asynchronous TypeScript lecture. This is the tool that we use to actually load external data, right? We use this fetch call, and fetch returns a promise. And so we have to use the .then functions to, once a network request, which might take a long time to kind of give an answer back. Once we get an answer back, we will convert it to JSON and then do something with it. And so what I'd like to do here is open up this example, and you can follow along as well. You can go to this link, go.unc.edu/426-L10, or if you have the slide open, you can click on it. And this will take us to StackBlitz here. And in StackBlitz, hopefully StackBlitz is working today properly, so it's going to take a minute to kind of get us set up. There we go. So we have our app. And the way that I've set this up is I've actually connected to the API that you'll be using for Wordle. So you can see here, there's this URL, https comp426apis.vercel.app/API/Wordle/random word. That's kind of the route. Once you make a request to this route, it gives us back a random 5-letter word that this game is going to be for. And if you notice in my code here that I have kind of written, there is this block for in here, this then block where we show an alert to the user. So you can see here that I loaded my data, and now I end up with this alert showing this word. All right. Now, I want to also show you here that I have a state that I have created called counter. And I have this counter state. I also have a button that says add 1 to counter. And whenever I press this button, I want my counter to update, right? This is a standard state, kind of like what we talked about on Thursday. And so I want to show you, though, that here, when I press this button, add 1 to counter, right? You'll notice that not only did my counter change, but also I got a new alert. I ended up getting a new word back from my API. You can imagine that this might be a problem. So in Wordle, for example, if I have a puzzle that my user is trying to solve and they make a guess, I want to update the grid to show them what their guess result was. I don't want to get a new word and then end up kind of restarting the game somehow, right? And so we've seen something like this before in last lecture, and so this is maybe a little bit of a warm-up question. But I'd like you to discuss with the people around you for a few minutes, why do you think that this shows up every time that we change our counter? Why do we get a new alert? Why do we get a new word? So that's question 1. The second question then that I want you to follow up with is, what happens, or what do you think would happen, if we added a state for the word, and when we load our data, we set the state to be that word? What would happen in that case? So what this would look like, and I'll kind of write it out here, might be something like const word, and then set word equals useState. And maybe this is just a empty string to start. And then I use my fetch call. So I fetch, and then I'm going to kind of abstract all this out. You can assume that there's a URL there that we convert it to JSON. So we get some result back, result. And I call set word with the result, right? Do you think that this will solve the problem? What will happen in this case? So I'd like you to think about both of these things. I'll leave the code up here and spend 3 to 5 minutes on this, then we'll come back and talk about it together. All right, everyone. Well, sorry, mic's not on. There we go. All right, everyone. I had a chance to discuss this. So does anyone have thoughts on at least the first bullet point only? So why does the alert show up every single time based on the code that we had that the button was pressed? Any thoughts here? Yeah. Exactly. Yep. So this is kind of what we talked about last time on Thursday, which is this idea that, remember, every single time that we change a state, we rerun the body of the component function, right? So if I go back here to my, let's see if I can, there we go. You can see here that this fetch call, right, it's not in any state, which means that every single time that we change our counter, we rerun this function from top to bottom, and therefore we call fetch every single time that we do so. So correct, all right? Any thoughts then on the second version? And I know, I apologize, I deleted it, but if anyone remembers, we create a state, and then we use the fetch, and then we set the state. Any thoughts on if that would maybe be a valid solution to fix this problem? Doesn't have to be correct. Any thought? There was some good discussion, so I know that some people have it. Okay, yeah. Yes, yes. Yeah. Mm-hmm. Exactly. Yes, perfect. So the problem with that, again, we say that we run our function every single time, our function body, when a state changes. And so because this is asynchronous and we have a promise, our set word function is going to be called every single time that we re-render, and calling set word is going to cause another re-render. So I'm going to show you this. So if I say const word set word equals useState with an empty string, and let's say that I now just, I'll do window alert word, which is our state. And then actually, I'm trying to think, what is the right way to go about this? I think I'll window alert, and then I'll set the word. So set word word like this. Okay. And I should do JSON.word and then do this. Sorry, I'm trying to make sure that this doesn't error out. Okay, I think this is fine. Yeah, this is fine. We'll just not use this variable. I think it should be fine here. And so if I refresh my page, what should happen here, and I might have to refresh StackBlitz again because StackBlitz sometimes I've noticed when I rerun these things, it doesn't actually do anything. Let's boot up. Installing. There we go. So you can see we have vague. And if I press close, we have shear. And if I press close, we have froze. And it just is an infinite loop over and over again, right? Because again, we're calling setWord, which triggers a re-render, and we just have this infinite process, right? So there must be a way then. We know these two things, right? We know that we have states in our toolbox, and we have these components. And there should be a way that we can load data in and then keep that data there, but we don't have to keep fetching it every single time that some re-render actually ends up occurring. Right? So again, the problem here, and this is going to be difficult for me to, there we go, close that. Right, so again, the problem is that every single time a re-render occurs, the function reruns. And so any statement that we have, any functionality that we have in our component just gets rerun every single time, which might not be the correct, what we want in many cases. Right, and I think this is what I said, right? So when if we want to load some data from an external system, for example, when our component loads, and then have it persist on future re-renders, so I don't have to keep duplicating it, we do not have a solution for that right now. And so what this is known as in this type of problem that we have, and this is widespread in the web community, so it's not just in React. There's also other frameworks, other tools that refer to the same thing, because this is often something that comes up. It might be called an effect. Sometimes it's called a side effect. So in this case, what we have here is known as a side effect. So definition for a side effect is just any action that our component takes that is not part of this loop of changing a state and then updating the UI. We want something to occur outside of that re-rendering process. That is known as a side effect. So you can see here, we have our component, we have our two arrows for updating our state and changing our UI, but loading data, if we want to load data and save it, we don't necessarily want that to trigger a side effect, or sorry, trigger a re-render. We just want it to happen once. And there are three main cases where something like this we might end up being triggered, or that we want something like this to be triggered. The first one is kind of the case that we already have. So most of the time, we do not need a special case for this. This can just be done in the way that we have been working with it with state, which is every time a component renders, we want some action to happen. Right? So there's no real special case here. That's kind of what we already have. We want to try and prevent that. The second situation is the one that we are after, which is that we might want some code or some functionality run the first time a component renders, but then on subsequent re-renders, we do not want that functionality to repeat. And then the third case is maybe we want some code to run only when specific states out of all of the states that we have in our component change. An example of this might be with, for example, Amazon.com or any product listing. Right, so maybe I have a search bar, or I have some filters that whenever I change the filter, I want to, or like type into the search bar, I want to change the results of what the user actually sees. Right, so maybe we load some product list to begin with using a fetch, but then later on, if I have some user interaction and I select a filter, I want to rerun that fetch, but only when the filter changes. Right, so if a user has any other interaction, such as adding something to the cart or doing anything else, we don't want to reload our data. We only want to reload it when a filter changes. So that's kind of our third case, is that we want to run some functionality when only maybe a few states or one state in our component changes, but none of the other ones. And so in React, there is a very nice tool that allows us to do this, which is known as the useEffect hook. It looks like this. You have a function called useEffect, and inside of useEffect, you pass in a void function, so a function that doesn't return anything. And that, well, Yeah, I think we'll violate that in a moment. But for now, you can just think it's just a function. It does something, right? Maybe fetching some data. We put it in there, and that is how our useEffect works. We don't save it necessarily to anything. And we can handle, the nice thing with useEffect is that we can use useEffect for the 3 different cases of handling a side effect that we mentioned. The first one, we want to run some code every time a re-render happens. The second one, the most common one that you'll probably see, is we want to run some functionality only once. And then the third time, when we want to, maybe we want to run it only when some states change. And so you'll see that it ends up looking like this. These are 3 different cases. We have the first one here running on every re-render, where we just have our basic useEffect hook. We have our function. Our second case here, we not just only have our function as a parameter to useEffect, but we also have an empty array. We'll get to this in a moment. And then the third one, when we want our code to run when certain states change, we have an array, but the states that we want our code to be dependent on are passed into that array. And so this array here in case 2 and 3 is what's known as the dependency array. The idea is basically saying that, well, in our base case here with useEffect, we're going to run that function that we pass in every single time a re-render happens, or we can supply an array, and anything, only when the things inside of that array change do we want to run this code. Right? So in the case over here, only when this one state changes do we want to rerun our code. And then the case that we have an array but we pass nothing into it, we're basically saying that no matter what other states change, we don't want this to rerun. It's just going to run once, and then it's not going to run again after that. Right? Are there any questions so far here? We're going to see some examples of this soon. Great. Okay. So I think let's go back to our example in StackBlitz to kind of see this work here. So let me go to my same link that I had, and I hope that it didn't save the infinite loop version, because that might be a bit of a problem breaking out of that. Okay, good. We're back in our original version here. And so let's use useEffect to try and load our word just once. When we load our component, we want our game to load the word, and then after that, whenever we change our counter, we don't want our word to rerun, right? So given that scenario, what type or which useEffect do I want to use? Do I want to use a useEffect with no dependency array, one with an empty one, or one with something in it? Anyone have thoughts on this? Yeah. Empty, exactly, right? Because we want this to load the first time that our component renders, but not other times. So I can use, just by typing in useEffect here, and I will first add in a function. This is the function that contains the functionality that we want to run only once. And so my entire fetch call here, I can take this and move it into the useEffect, like so. And then the second thing here is, yes, I need to also add in my dependency array, but it's empty because we only want this to run on our first re-render. And so now and unfortunately, because I think this is broken again from what I can tell, yeah, I should probably figure out. I think the problem is that it's slightly unreliable in Safari. So maybe at some point in the semester, I'll learn my lesson and not open this in Safari. So that we don't wait around for StackBlitz. There we go. So you can see the first time we load our page, it shows a word here. And then I press close. And then every single time now that I add to my counter, it does not end up changing. All right. I'm going to now extend this example to create another state here for our, let's say, counter 2. And I'm going to add a button for add 1 to counter 2. Just to show you how we can limit this to only run when we change a certain state. So let's say in this case that I don't want my, and actually I should put counter and counter 2 here. There we go, save, and unfortunately, I think we're broken again. Anyway, so let's say that I want to run this particular alert and refetch my data only when the second counter changes, but not the first one. How would I modify my current useEffect to to make that functionality work? Any thoughts? Anyone want to? Yeah, yeah, exactly. Yep. Because this array again tells us it's the list of items that says when anything in here changes, this is going to trigger our code. And so we want to just put in counter 2 in here. So I'm going to save and I'm going to refresh my page here. Um, Also, I want to say last semester, this did not happen. So it must be a newer thing because I feel like I used StackBlitz and we didn't have any bugs, but this semester we're having some issues. Okay, there we go. So we have proud show up here. And notice that when I change counter 1, nothing happens. But when I press change counter 2, we end up running this. Okay, so this is a way to kind of have code run conditionally as states in our program change. Are there any questions here? All right, perfect. So I want to make sure I'm not missing anyone. Nice. Okay, so we've introduced useEffect, and we've particularly used useEffect with fetching data, right? Because this is one of the core use cases of useEffect, especially in your game, in Wordle and connections. We don't want to be reloading a new game while users are playing. So we want to make sure that we limit it to only load once when our page loads. And so therefore, we need a useEffect hook. And there are many cases where we'd want something like that to happen in a lot of websites that we load some data in. And so let's jump forward here. Fetching data is our main example of where our side effects or use effects are useful. Another one is setting up global event handlers. So you already saw in the reading and also in our last lecture that we can, in TSX, directly apply event handlers to components, right? So instead of having to manually create an event handler on a button, I can simply have something like button and then on click like this, and then pass in some function into this. Right, so that works, except there's a special case because there's some type of events that happen on the global window. For example, keyboard. Clicking on the keyboard is one because when you click on a keyboard, it's not specific necessarily to any particular component. It's just a global event that happens. Another one, scrolling. So if you have some animation depending on when you're scrolling, right? That's not dependent on any particular component. That's like a global event handler. And so if you're setting up a global event handler where you need to do something like window.add event listener as your code, you might want to do that in an effect. And again, the reason here is because we want to create an event handler once, but we don't want to have and keep adding redundant event handlers every single time a state changes. We could end up with hundreds of event handlers then, which can slow down our site. And also, that's a bit of a hint because, again, one of the extra credit parts of the assignment for Wordle is actually getting the keyboard to work. So a little bit of a hint there in terms of what you might have to look at to get that working. And again, I already said this, without useEffect, you'd end up adding a new event handler every single time you re-render. Another one is storing and loading data. One thing we didn't necessarily talk about yet, and actually I think that this was implicitly in your Pixel Art Maker assignment, even though I didn't necessarily say it outright, which is that your browser, and we kind of maybe very briefly mentioned this in the browser lecture, browsers have an internal storage called local storage, which you can store things in as you need them. So in A02, we saved your, every time you made a change to your canvas, we saved it in the browser. So if you went to the website again, we could retrieve it, right, from storage and continue working on it. Well, if we're trying to load we're trying to load a previous drawing that we made, we don't want to load the drawing every single time we paint a new pixel, right? Because then we're never going to be able to draw anything new. It's just going to keep resetting our puzzle back to the previous version. So this is another example where we don't want maybe loading and saving data to be happening every re-render. We only want it to happen in specific cases. Setting timeouts. So if you had set timeout, if you want some delay to happen, like you want something to happen 2,000 milliseconds in the future, every single time that you re-render, you wouldn't want to create a new timeout sometimes. So you can use a useEffect for that. Any questions here? All right. So another important note here with useEffect, and this is why I corrected myself, because useEffect doesn't have to return a void. if you have a return statement in your useEffect, it will return what's known as a cleanup function or cleanup handler. And essentially what's going to happen is that function is going to run when your component gets destroyed in some way. So for example, if your component, we call it unmount. That's kind of the terminology they use in the documentation. All that's saying is we're removing it off of our screen. So maybe we switch to another page. We don't use the component anymore. And this is really useful to prevent various problems like either memory leaks, or maybe, for example, we set up an event handler for the keyboard on one page, but then we go to another page, we don't want that event handler to stick around. We want to make sure it's gone. And so we can add a function here that we return from within useEffect, and that function will specify the behavior of what we want to run when our component disappears. So in this case, you can see I set up a event handler for scrolling. But then when I maybe change my page, I want to remove it, and I'll put that in here. So this is sometimes a best practice. You don't need it all the time. It's only in specific cases where maybe, again, like event handlers, or you're doing something that you want to clean up after yourself, you have the ability to do so. Any questions so far? All right. Now, there is a very big caveat with this particular lecture, and if anyone has worked with React before, or maybe worked on a project like this, you might know what I'm going to be referring to here, which is that you do not need to use an effect for everything. And what you find in a lot of projects, especially React projects, the documentation isn't necessarily the clearest on what a side effect is. People use, therefore, then side effects, or the useEffect hook in a lot of places where they probably don't need it. And it ends up creating a lot of bloat and a lot of problems in projects, right? Because in order to really understand useEffect, right, and you have to understand the re-rendering cycle, the fact that we rerun our component every time a state changes, all that kind of stuff. And if you're not aware of that, or you kind of rush to use an effect, your project can end up in a bad state of many, maybe months in the future, as you keep adding and you have dozens of unnecessary use effects. And in industry, this has been a problem, which is why in the update of the React docs, they added a dedicated page for all the reasons why you should not default to using a use effect. Okay, so useEffect is a very useful tool for the things that we talked about, like loading data. We go back to our list. Right? These things, very good for using useEffect. But there are other cases where it is not so useful. And so we're going to explore that here. The main one to note, you do not need to use effects to compute properties based on state. Let me show you what I mean by that, because the docs, and I recommend you read this. It's not part of the reading or anything, but it's a very good read if you want to learn a little bit more with React. And if you're working in React in industry, this is definitely a page you should read, which is this case here, right? So let's say that we had two states, first name and last name, and we wanted to figure out the full name, right? The concatenation of the first name and the last name. Well, we could, in theory, create a new state for the full name, and every single time the first name or last name changes, we re-render and we change our full name to be the concatenation of the first and last name, right? This is valid, and it works, because you do have a first name now, and every time you have the full name now. Every single time first name or last name changes, we generate a new full name. We can do this, and it works in theory. The app does work, but we've added unnecessary handling here. We do not need a state and a useEffect to do this, because remember, and we talked about this a little bit last time, is that you can create calculated values just by creating regular variables, right? Because again, remember, every time that my first name and last name changes, I'm going to ultimately be be re-rendering anyway. And so we can just instead do const full name equals first name and last name. This will do the same thing, because if either of the names change, we rerun our function and we calculate a new full name. Okay? The problem with this version, right, is that we end up creating this, by calling set full name here, right, we end up triggering an unnecessary re-render. Because we re-render when first name or last name changes, that's our first re-render, and then we set full name, which has a second unintended re-render. And in our version here, if either of these change, we only end up with one re-render because it re-renders and then we calculate, we don't do anything else, right? And so there are various tools, and maybe if you've seen online, I know that there's been some talk about this, and you can probably find videos of people using, there's like benchmarks that you can run on React, and it will tell you if there's like unnecessary re-renders or when your site's re-rendering for the sites that use React. And there are some even big apps that exist out there where you open a page and there's like hundreds of re-renders happening all the time because, again, somebody somewhere when they're developing this used too many kind of use effects and use states. All right, so this is just something as an optimization thing. It's very important to kind of keep in mind. Are there any questions here? Perfect. We're moving a lot faster today, I think, than I assumed. So that's pretty pretty cool. So that means that we have more time, I think, for this example, which I think will be helpful. So this is our attendance check for the day. So you can work on this in pairs. I have a component here, and this component is going to show me a list of songs. You can imagine maybe I'm in Spotify. I have a list of songs. I pass in those songs as a parameter. So we have a prop in. And then on the second line there, we have this line for const curated songs. And we essentially run this function called filter and sort songs. You can see we define this somewhere. That takes our songs, maybe it runs some algorithm to figure out what we want to listen to, or maybe it's a shuffle or something, and it gives us our songs in a list. Now, I've made a comment here to assume that this is a particularly maybe slow algorithm. So maybe it's O of n cubed, maybe it's even worse. Maybe it's like some power, like exponential function, like O of 2 to the n. Again, this is just for demoing purposes that I'm saying that this is very, very inefficient. And then you notice here that I have a list for selected, for my, sorry, not a list, I have a state that's keeping track of my selected song. And so every time I click on a song, I select it. So maybe I have a list, I click on a song, and we're just saying that I change and re-render my component so that selected changes, right? And so in my scenario, let's say that I'm a very indecisive listener. I'm clicking on new songs I'm just like flicking through them. I don't know which one I'm listening to. I'm just clicking around. And when I'm doing so, I'm noticing that my site feels very choppy and very slow. And things are kind of flickering around and a bit sluggish. I want you to think about why that is the case and for the next 3 minutes. And then we'll talk about it, and then we'll figure out maybe how we can improve this so that we remove that problem as we in a refactor. So give around 3 minutes for this, and then we'll come back together. All right, everyone, make sure that you have something written down in Gradescope for the submission. And while you all submit, does anyone have any thoughts on this? It's a lot of good discussion, so maybe someone new as well would be. Yeah. Yes, exactly. Right. So in case you didn't hear, she was saying was that this function here, this filter and sort songs, is a very expensive operation in the sense that it has a very high time complexity. So it might take a while to run. And every single time I change the song that I've selected, I change my state, and changing the state triggers a re-render. We rerun this function, and therefore, every time we change our song, we end up having to rerun this expensive filter operation over and over, right? So using kind of what we learned, we can think about, okay, we have this scenario. This is a real life scenario that could happen when you are developing applications where you have some operation that's slow to do, or you have like an algorithm you have to run, and maybe something you learned from like 550. And hopefully, if you pass 550, you're not writing algorithms that are O of n cubed, but who knows? It can happen, right? So in this case, how might we be able to solve it? Well, the first thing that we might think about is, well, again, using our toolkit. We know of useState and we know of useEffect. Well, whenever I use useState, right, and I set the value of my state, I don't end up having to, every time it re-renders, that value is persisted. So I could try to solve this using just a state hook like so, where I have a state and then I pass into it as kind of the initial value, the result of this function. So it runs once. It's an expensive operation, but then afterwards, because that state doesn't change, we don't end up ever recalculating. Right? So in this case, now curated songs is not calculated every re-render. There is a problem here, though, that this does not necessarily include. And that problem is, well, what if our input, our list of songs, ends up changing? What happens in that case? Right, so you can imagine maybe this list or a song list component is inside of like a playlist component. User can add or remove songs from their playlist. And when they do so, this might end up needing to change. Because if we add a new song, in this case, well, that song's never going to appear in our curated results because it doesn't end up getting rerun. And so kind of this is an example of what we might look like, or what this might look like. We have a playlist component. We have our playlist, and we pass that in, and maybe our playlist changes. So knowing now what we have kind of learned here with our two different tools, how might we make it so that we change that state and we change our list of curated songs when our input changes here? Any thoughts? Yeah. Exactly. Yep. We can remember, useEffect is this tool that we can use to run code either the first time that a component renders or when states change. And so in this case, if our input songs changes, then we want to rerun our filter. And this works in this particular case. The reason, if you might be wondering, well, why wouldn't this be infinite? It's not an infinite loop here because remember, we have set our dependency array to songs, and what we're changing is curated songs, not songs, right? So changing curated songs does not re-trigger this useEffect. Only changing our input list ends up triggering it. So the combination, you can see here, the combination of both of our tools, both the state and an effect, both together allows us to essentially perform some expensive operation, keep it there, and then only when we need to rerun it will we rerun it, whenever our songs changes. And this is a very core, actually foundational software engineering problem that comes up. So the idea of kind of preserving or caching out the result of some operation that might take a long time to run. Every single time we re-render or maybe something changes, we don't want to recalculate it, but we only want to recalculate it when we need to. That is known as memoization. Okay, so memoization is this idea, again, where if we have some function, we only want to run that when we need to run it. In this case, whenever our playlist maybe or our song changes. Right? If we select, though, a new song, we don't need to rerun this because ultimately we're not changing our list of songs when we do so. Right? And so this is a very common pattern. And in fact, once we're later in the class, we have some more advanced assignments, you will see this come up because there are operations that we need to perform, and we can make it more efficient by memoizing our result. And in React, React also makes this easier because you notice here we need two different hooks. We need a useState hook and we need a useEffect in order for this to work. One to store our cached result and the other to trigger a change in that result, right? We need both of those tools. Well, with React, there's a special hook that they also provide called, and this is a bonus here because you can do this without it, but this is a nice shorthand called useMemo. So the useMemo hook is a combination of our state and our effect hook, and it allows us to essentially do what we wanted in terms of memoizing our value by combining both of these. So what happens here is we have instead, remember the useEffect, if we go back, right? useEffect didn't return any value. It just ran some code, right? So there wasn't like const curated songs equals useEffect, right? That wasn't a thing. So here we actually have a value that's being set for curated songs. And the result of it is that we want to run that function, right? Filter and sort songs. And we only then want this value to change whenever my songs changes. So it still has the dependency array from useEffect, and it looks very similar to a useEffect. The only difference here is that it is actually returning and storing a value, and that value does not get recalculated unless one of the values in our dependency array ends up changing. Are there any questions with this? All right, so there's also there's more, even more advanced stuff that React has to try and make things more efficient. You will see that later, though. We're going to kind of just use useState, useEffect, and then you might see useMemo for now. But there are so many different tools in React because React is used to build really big and really complex applications, right? So there's all these different cases that they need to consider. And so efficiency in this aspect, we talk about efficiency in a lot of classes like 210 and 550, but this is kind of a real world example where efficiency actually has an effect on the user. And so we need to make sure that we handle cases like this in a way that doesn't hinder our users' experience, because maybe they will not use our website anymore and use competitors or et cetera, right? So this is very, very important. So this is a rare feat here that we actually finished a bit early. So if you do not have a partner yet and you want to find one for A3, you can feel free to use the time to do so. You can also get started on A3 if you like, or if you want to fill out the form, you have the time to do so. But otherwise, that is all. We'll see you on Thursday to continue our discussion on building websites with React.